Hello guys, welcome to our YouTube channel. In this video, we'll be solving problems under electric circuit. But first, please hit the like button and subscribe. Before solving any problems, I would like us to first do a recap. We will start by defining Ohm's law. Ohm's law states that the potential difference across the conductor is directly proportional to the current that flows in the conductor, provided that the temperature remains constant. So basically, it means that if we increase the voltage in our circuit, the current will also increase because voltage and current are directly proportional to each other. We'll show you an example here. Let's say I double the voltage and make it 12. As you can see that the current also doubles. And if we increase the resistance in our circuit, the current will decrease because resistance and current are inversely proportional to each other. If I can try to double the resistance here, you can see that the current will decrease by the factor of 2. Okay, here's the mathematical formula for Ohm's law. Where the voltage is measured in volts, the resistance is measured in ohm, and the current is measured in ampere. Secondly, we will discuss circuit connections. Circuits can be connected in series or in parallel, or they can be combined at some cases. Let us look at properties of circuit that is connected in series. The total current that is supplied by the battery is the same as the current that flows through R1. It's also the same as the current that flows through R2 and so on. And then we have the voltage divider. The voltage will be divided in each resistor. Therefore, our total voltage will be V1 plus V2 plus V3. Lastly, our total resistance can be obtained by adding the resistors. Add the properties of a circuit that is connected in parallel. As you can see now, we have branches here. The total current that is supplied by the battery will be divided here in each resistor. Therefore, our total current will be equal to the current that flows in R1 plus the current that flows in R2 plus the current that flows in R3. And then our total voltage will be the same throughout. Resistors that are connected in parallel have the same voltage. Lastly, we can obtain the total resistance by adding the ratio of resistors. Now I will show you how to solve complex problem using the information that I just shared with you. Here we are given a circuit diagram with incomplete information. As you can see here, we have an unknown resistor that dissipates the power of 5.76 watt, and we have branches here. These two resistors are connected in series, but they are connected in parallel with this resistor. Then we have a voltmeter here that is measuring a voltage across this resistor, 6 ohm resistor. Okay, I will name this resistor R3, and this will be R2, this will be R1, this will be Rx. Here we have an ammeter. Okay, ammeter is an instrument that is used to measure a current. Here we have a switch, and then here we have a voltmeter that is measuring a voltage in the battery. Okay, let us do the following questions. If switch S is open, this switch, they say write down the reading on V1. Okay, V1. Where is V1? Here's V1. If we open switch S, what will happen to V1? Well, what will be the reading on V1? Okay, as you can see here, once we open the switch, we are breaking. It's like we are removing all this part. This part is no longer functioning. We only have what? The battery. And the total voltage in the battery is 12 volts. Therefore, the reading in V1 will be equal to 12 volts. Okay, question number 2. A reading on V2. Where is V2? Here's V2. As I said before, that if we open switch S, this part from here, this part is no longer functioning. So our reading on V2 is going to be 0 volts. Okay, now we close switch S. Switch S is closed. Now we have a complete. S is now closed. If switch S is closed, we will now have a current that is circulating in the whole circuit, and the reading on the ammeter is 1.2 ampere. So the current that flows in this section is 1.2 ampere. Define the term power. Power is the rate at which work is done. Simple definition. Next question, calculate the resistance of resistor X. Where is resistor X? Here is resistor X. Okay, we already have the current that flows through resistor X, and we have the power that is dissipated by resistor X. So we can simply use this formula to calculate Rx. I'm sure you're all familiar with this formula. Then we can make R the subject of the formula. Rx will be equal to P divided by I to the power 2. Therefore, let us substitute Rx will be equal to power, which is 5.76, divided by the current that flows through Rx, which is 1.2 squared. Equal to. So our Rx is equal to 4 ohm. Okay, let's do the next question. The next question wants us to calculate the total external resistance of the circuit. The total external resistance. Okay, as you can see here, I said before that sometimes you can have the combination of a parallel and a series in one problem. So first you have to calculate this part. As you can see that these two resistors are in series to each other. So I will just say, I will name them RA. I will say RA is equal to R3 plus R2 plus R2 equal to 8.4 ohm. So 2.4 ohm plus 6 ohm is equal to 8.4 ohm. Okay, and these two resistors are in parallel with this resistor, which is 6 ohm, and we named this resistor R1. Here it is. So I will say, let's say RB. We'll name this part RB is equal to okay, RA multiplied by R3, which is 6 ohm, divided by the sum of these two resistors plus okay. So the equivalent of this part is equal to 3.5 ohm. Then this equivalent resistance is in series with Rx. Therefore, we can have our total external resistance. Total external to Rx is Rx is equal to Rx, which is 4 ohm, plus the equivalent of this part, which is 3.5 ohm, equal to 7.5 ohm. There you have it. In the last part, we are required to calculate the reading on voltmeter 2. Here is voltmeter 2 measuring the voltage across this 6 ohm resistor. So in order to calculate this voltage, we must first find the current that flows through this resistor. So how can we do that? Well, here we are given the current that comes in and will be divided in these two branches, and that current is equal to 1.2 ampere. So 1.2 ampere will be divided into I1 plus I2. I1 is the current that flows in this part, and I2 is the current that flows through these two resistors. So we are looking for I2, but now we have an unknown of I1. But how can we find I1? Well, let's say 1.2 is equal to I1 is equal to voltage divided by, since this current flows in this resistor, we will use this resistor, which is 6 ohm plus I2. Now we have another unknown, which is V2. Just V. And V is the voltage across this resistor. So we now have to remember that the voltage across this resistor is also the same as the voltage across these two resistors. That is the property of the parallel part. So we can also expand I2. 1.2 is equal to V divided by 6 plus V divided by the sum of these two resistors, which is 8.4. Then now we can solve V, the voltage across this resistor, which is 6 ohm. Okay, 0.2 is equal to, we can add these two values. Let me hit the calculator. Okay, equal to 2 V divided by 7. Then let me do some math here. We'll cross multiply here. 2V is equal to 7 multiplied by 1.2, which is equal to 8.4. 8.4. Then if we divide by 2 here, we'll have 4.2 volts. Then we have the voltage. Remember I said that this voltage is the voltage across 6 ohm. It's also the same as the voltage across these two resistors. So if I have the voltage across these two resistors, I can able to calculate the total current that flows in these two resistors, and that current is I2. So I2 is equal to 4. I2 is equal to 4.2 divided by this, the equivalent resistance of these two resistors, which is 8.4. So our I2 is equal to 0.5 ampere. So now we have the current that flows in this resistor. Then we can calculate V2. V2 will be equal to I1 multiplied by 6 ohm resistor, which is equal to 3 volts. There you have it. I hope you understand how I got V2. If you don't, please post the question below. I will try to answer your question. Thank you for watching. See you in the next episode. Bye.